Gravitational waves. The concept of gravitational waves is a long-standing idea. Albert Einstein briefly covered them when he explained that ripples of spacetime, known as gravitational waves, occur when large bodies orbit each other. He made these predictions in the development of the general theory of relativity in the year 1916. The calculations associated with the idea revealed that huge bodies, such as black holes and neutron stars, encircling each other at high speeds, would cause ripples that would move outward from the source in all directions. Einstein added that the undulations would travel at the speed of light. This concept has been studied for many years, and none of the experiments conducted have provided conclusive results to validate the claims. That was until a few years ago. On September 14th, 2015, the first successful direct observation of gravitational waves was recorded by the Laser Interferometer Gravitational Wave Observatory, or LIGO for short, in Louisiana and Washington. Scientists have researched gravitational waves for many decades since Einstein predicted their existence over 100 years ago. His calculations regarding the bending of light by the sun set the stage for further studies that validated his theory. The same year he made his theory, one paper argued that if space were like a trampoline that can warp and curve, tapping it would cause undulations that would be ripples in the fabric of space, thus explaining the concept of gravitational waves. The calculations included in the paper were erroneous, but Einstein corrected them 2 years later in 1918. Other scientists developed a systematic framework that authenticated the claim that gravitational waves were a real phenomenon. In the video titled Gravitational Waves, A New Era of Astronomy Begins, the LIGO team explains that the waves stretch and squeeze space. However, they are so small in magnitude that it is difficult to detect them. This problem was solved by scientists involved in the project, namely Rai Weiss, Barry Barish, Nergis Mavalvala, Franz Pretorius, and David Shoemaker. In the video, they discuss the concept of gravitational waves, the journey to discovery, and what the future holds for the field of astronomy. One of the most foremost scientists to study the phenomenon was Joe Weber, who conducted an experiment and claimed to have observed gravitational waves. However, his results were doubted by many who distanced themselves from his research. Weber was unrelenting and held on to his findings. Scientists were very skeptical of the possibility of observing the waves. Richard Garwin, a physicist from IBM, conducted similar experiments to evaluate Weber's claims. His detector caught a single pulse, which was attributed to noise. Studies continued until a breakthrough was attained by LIGO in 2015. The LIGO team was skeptical of the results after observing the waves and attributed them to an accidental or intentional process within the project. In the fall of 2015, rumors spread before the issuance of an official statement that the team had discovered gravitational waves. They were apprehensive because they had not confirmed that the signal was a gravitational wave and not the result of an injected signal. Moreover, the detection apparatus was in the testing phase. Weiss explains that the event had occurred 1.3 billion years ago, and that it involved the collision of two black holes that caused waves that rippled through space. The observatory detected the signal as it passed through planet Earth. The scientists explained that the observatory was coincidental because the wave appeared at a time when the observatory was in the testing phase. The detection was also made possible by the contribution of Pretorius, who had been studying black holes for more than 2 decades. One of the challenges they faced was the fear of sabotage, as the results had to be similar in both the Washington and Louisiana stations. A previous experiment conducted at the South Pole by BICEP 2 had reported the discovery of gravitational waves. However, further probes revealed that the undulations had been caused by galactic dust. Prior experiments had been worse, and the group had made significant improvements to the technology used. However, their results were wrong because of using insufficient detectors and a lack of peer review. Franz was responsible for the numerical aspect of the discovery and provided solutions to the field equations of Einstein's theory of relativity. The first answer to the equations was provided in 1915 by Carl Schwarzschild, and it turned out to be the first black hole solution. In 1963, Roy Kerr developed an explanation for calculations involving rotating black holes. Colliding black holes lack symmetry. Therefore, scientists took several years to compute answers to related field equations. The development of computing led to a breakthrough that resulted in the 2015 discovery by LIGO. It has been hailed as a historical event in the history of modern science because a gravitational wave is the most energetic astrophysical object observed since the Big Bang. Be sure to subscribe for more Space Rewind and tell us in the comments what you would like to see next in an upcoming video.